Okie dokie, guys. This is chapter 33 in the Pharmacy Calculations book. We're going to discuss infusion rates and drip rates. I did a couple problems, but I just kind of want to go over it just to do the video really quick. Okay. So let's start with the introduction, I guess. Physicians write down orders for rates at which an IV is infused into a patient. Infusion rates can be expressed as numbers of mLs per minute, mLs per hour, amount of drug per hour, and often as length of time for a volume to be infused. So basically, you can infuse it at 125 ml per hour or 1,000 mLs over 8 hours, or infuse 10 milligrams per minute, etc. So something per something, basically volume over time. Okay. If the volume of the infusion and the time of the infusion are known, then the rate of the infusion can be calculated from the following formula. So basically this little formula here, volume over time equals rate, is one formula that we need to keep in mind when doing these problems. Okay. The first example, since it's on the page, we'll go ahead and complete it. It states to infuse 1,000 ml over 8 hours. So in this case, we do know the volume and we do know the time. So what we'll get is the rate. So if we divide 1,000 ml over 8 hours, our rate will be 125 ml per hour. Okay. In the second example, the time of an infusion can be calculated using the same formula. For example, if the rate of the infusion is 100 ml per hour and the volume is infused in 1,000 ml, how long will it take the bag to last? And if you go by my past videos, you know that I do the crisscross method. This is shown a little different. So basically you would do 1,000 ml over time equals 100 ml over 1 hour. And then you would crisscross and do your 100 ml per hour. It's the same thing, it just looks different. And you would get the 10-hour answer. Okay, so once you do the crisscross, so 1,000 by 1 hour equals 100x. Then you would just divide by 100, your 1,000 by 100, and you would get your hour as 10 hours. Okay, so that's basically the introduction as far as these are concerned. Let me just do a quick brief review to make sure that I didn't leave anything out. So what we should know, let's continue a little more of the information. It says conversions are made to a flow rate of drops per minute from infusion rate ordered by physicians. To convert a flow rate in ml per hour or to drops per minute, 2 steps are involved. To convert flow rate to hour and drops per minute, the 2 factors that are needed is 60 minutes in an hour, and the second conversion factor is to determine the drops per ml. And the number of drops per ml is determined by the size of the tubing and the nature of the administration set. Okay, so as we get into the examples, we'll get more into the all of that. All right, so let's see. I did a couple. Let's see here. And I'm just going to explain my thought process or the way I did it, as I did it, because my view is a little different here. Okay. So number 1 states if a liter bag of dextrose 5 and water is run through an IV into a patient's arm over 8 hours, what will be the rate of infusion in ml per hour? Again, this one is the volume over time, and you get the rate. Okay, So you just divide the 1,000 ml because that's what a liter is. Okay, 1 liter equals 1,000 ml. Divided by 8 hours because that's what it's telling you it's going. So 1 liter divided by 8 hours is 125 ml per hour. And that's how you get that answer. Okay, so the only thing you kind of did in this was convert the liter to 1,000 ml and divide by each other by 8 hours. Okay, number 2, if a 500 ml bag of 9% sodium chloride injection is run over 8 hours, what's the rate of infusion? Okay, so you have the 500 ml, you have the 8 hours, you divide in order to get your 62.5 ml per hour. Okay. Let's go into number 3. If a 1,000 ml bag of normal saline is run at 100 ml per hour, how long will the bag last? Okay, so this is how I did my crisscross, just like in the last example. If you have 100 ml per hour and you need 1,000 ml, and you have 1,000 ml to distribute basically, or to put into the body, how long will that take? So you, again, like you know, I do my 3 pieces. If you have 3 pieces, you can always find your fourth. So you know your first piece is 100 ml, your second is 1 hour, and then you have your third piece is 1,000 ml. Okay, so you're 1, 2, 3, and you have your X. That's your fourth piece. So 100 ml divided by 1 hour, or 100 ml is equal to 1 hour. What is 1,000 ml equal to? Pretty much is the question. So then you crisscross 100x, 100x by 1,000, divide by 100 because you need to isolate your X, and you get 10 hours. Okay. All right, let's get into number 4. Number 4 says a sterile solution request form is received for a large volume parenteral. The infusion rate is 125 ml per hour. The nurse requests enough 1 liter bags for the next 24 hours. How many bags do you make? Okay, so first off, we do the crisscross. We have our 3 pieces. We're asked, or we're told that the infusion rate is 125 ml per hour. So 125 per hour. Okay, and we have 1 liter bags to work with. Okay, so 1 liter bags are 1,000 ml each. So you have 125 ml per hour, and you need to continuously work with 1 liter bags for the next 24 hours. So since you have your 3 pieces, 125 in 1 hour, and your 24 hours, you're looking to figure out how many mLs you need ultimately. Okay, so you have 125 for 1 hour, and you need to know how many you need for 24 hours. So you crisscross your 1, 2, 3 pieces, and you're looking for your X. You crisscross, you get your 1X equals 3,000 ml. The reason why you're dividing by 1,000 ml is because 1 liter, okay, equals 1,000 ml, and it's asking you to refer your answer into bags. Okay, so your answer will be bags. It's asking how many bags do you need, and each bag is 1,000 ml or 1 liter. So that's why if it gave you the option of saying 3,000 ml, then that would be a good option. But because it's asking how many bags do you need, and you know that each bag is 1 liter, and you know that 1 liter is 1,000 ml, you ultimately divide by 1,000 ml to get 3 1 liter bags. Okay. All right. Number 5. If the infusion rate for an IV is 80 ml per hour and it's run for 4.5 hours, how many ml has the patient received? Again, you have your 3 pieces. Your infusion rate is 80 ml per hour, and you want to know how many ml, which is your X, is run or ran into 4.5 hours. Okay, so in If you run 80 in 1 hour, how many will you get in 4.5 hours? That's the question. Okay, so you crisscross your 80 times 4.5 and your 1x, and you get your 360 ml. Number 6 says if a liter of D5W is started on a patient at 1400 hours, which is 2 p.m., okay, on a Tuesday, at what time and day will the next liter be required if the rate is these right here? Okay, so if the rate is 125 ml per hour at this rate, basically, the next bag will be needed at 2200, which is 10 p.m. on a Tuesday. Okay, and this is just simple crisscross. I did some extra work here. Okay, so basically what you do is you get all of these problems, your 125, like, because we're here right now, I'm going to show it to you here. Same thing. You have 1 liter bags, okay, and your infusion rate is 125 over 1 hour, and you have your 1000 ml. These are your 1 liter bags. It's your third piece. And the reason why you're placing it on top is because mLs go with mLs, hours go with hours. So because you're searching or seeking the answer of hours, your X will be on the bottom. Okay, so that's how you set up your proportion. So 125 over 1 hour equals 1000 over what? So then you do your crisscross. 125x equals 1000 divided by 125 in this case, in order to get 8 hours. Okay, so how do you get this? Because you started at 1400, which is 2 p.m., 1400 in addition to the 8 hours that you needed. So 8 hours, right? You need, and you have it at 1400. So you basically need to hang the next bag 8 hours from the 1400, which is 8 hours plus 2 p.m. is 10 p.m. So your next bag will need to be hung at 10 p.m. on that same Tuesday. Okay, same difference here. Instead of the 125 over the 1 hour, we do the 80 over 1 hour. Okay, if we did the 80 over 1 hour, we did our whole crisscross with the 1000 ml, same way. Okay, let me see if I could just stick that in there. Same way, rather than putting 125 over 1 hour equals 1000x, we put 80 over 1 hour equals 1000x. And in that case, we get 12.5 hours. Okay, 12.5 hours, 12.5 hours from that 1400 hour on a Tuesday gives us 2:30 in the morning on that following Wednesday. So 2:30 in the morning. Okay, now same thing, 200 ml per hour, you get 5 hours later. Okay, so 5 hours plus over the 1400. Let me see if we can get that in there both together. Okay, so 5 hours in that 1400 on a Tuesday gives you 7 p.m. on a Tuesday, on that same Tuesday. So you would need to hang the bag at 1900, which is 7 p.m. on that same Tuesday. Okay, so basically what you're looking for is you're looking to see how many hours, how do we put this? How many hours does the equation give you? And then you take those hours and you add them to the hours, the hour that you're provided, right? You're provided 1400, which is 2 p.m. on a Tuesday. So if you add the 5 hours that you get from this problem, 5 hours from 2 would give you 7 p.m. on that same Tuesday. Okay. Same here, 50 cc's, which is also 50 ml per hour. You do the crisscross with the 1000 ml. you get 20 hours later. 20 hours after the original 14, or 20 hours after the 2 p.m. on a Tuesday gives you 10 a.m. on a Wednesday. And you can pretty much go over that again. If you don't understand it, just review that again. So what you're looking to do is figure out how many hours this lasts, and then attach it to the hours on the from when you originally started in order to hang your next bag. Because this is basically asking, when are you going to hang your next bag? If your patient just came in at 2 p.m. on a Tuesday and you're giving him this rate, when are you going to hang the next bag based on your calculation? So in this case, for example, you're 125 per 1 hour. It lasts a total of 8 hours to get this treatment. So the next bag will have to be hung at 10 o'clock, because then there will not be any more. Okay? All right. Let's see. I did 2 more here. Let's see, are we focused in there? Kind of, sort of. Okay, wait a minute. Okay. All right, that's better. Okay, so number 7 says potassium chloride 30 MEq is to be given in 1 liter of IV fluid. The infusion rate is 125 ml per hour. How many MEqs per hour are being infused? Okay. So, in this case, you're looking at the MEqs per ml and not per hour, okay? Because it's a little bit different. Okay, potassium chloride 30 MEq is to be given in 1 liter. So 30 MEq in 1 liter is your first 2 pieces. And then your rate is 125 ml per hour. So 30 MEq to 1,000 ml is how many MEq? Because it's asking MEqs per hour, and 125 ml per hour is pretty much the same thing. So you only do 1 conversion anyway. So because it's asking how many MEqs are being infused, you start by searching for the MEqs. So 30 MEqs in 1,000 ml is how many MEqs in 125 ml. Because 125 ml per hour is the same thing as MEqs per hour. Okay, so then you crisscross your 30 by 125 and your 1000x. Okay, 1000x equals 1000 times x is 1000x. 30 MEq by 125 ml is 3750 MEqs. Okay, MEq. You divide by 1000 in order to get 3.75 MEqs. Okay, 3.75 MEqs per hour. And it's the same thing, because 125 ml per hour is how many MEqs you're going to give per hour. Same thing. Okay. And number 8, a 50 ml IVP piggyback of ampicillin, 500 milligram in normal saline, is to be run over 20 minutes. What's the infusion rate in ml per hour? So since you're working with minutes, you have to convert your hour into minutes, okay? So you will get your 50 mLs into 20 minutes, which is your 2 pieces, all right? Equals how many ml in 60 minutes? Okay, 50 ml bag of ampicillin 500 milligram in normal saline is to be run over 20 minutes. So 50 ml over 20 minutes is what your pieces should be. This 500 milligram in normal saline you do not need to get the rate per hour. Okay, that's just extra. So 50 times 60, 3,000. 20 times x, 20x. So 20x equals 3,000 divided by 20. You get 150 ml per hour, or per 60 minutes, which converts into hour. Okay. So the only extra thing here that you had to do was to convert the minutes and the hours into minutes in order to get the correct conversion. Since you're looking for hour, you make it into 60 minutes instead of 1 hour. Okay, let me see what else we have here. I did a few more. Let me put that to the side. Okay, I don't know, what did we leave off? I also did number 26 and number 14, which had a couple more steps. Okay, so in this case, a physician orders a drug to be infused at 10 microgram per kilogram per minute. 10 microgram per kilogram per minute. Okay. The patient weighs 70 kilos, so that means the conversion is okay. Like our kilos, and we're working with kilos, so we do not need to convert pounds to kilos, for example. We have the conversion. So we know so far that 10 micrograms per kilo per minute would give us our first part, right? Which our first part is 10 micrograms times 70 kilos is 700 micrograms per minute. Okay? That's our first part. Patient weighs 70 kilos, we need 10 microgram per kilogram per minute. So in total, for this phrase, we know that 10 micrograms per 70 kilos, right? Because it's per kilo, per 70 kilos is what we get our 700 microgram per minute. First part, all right? Second part is the total dose the patient is to receive is 21 milligrams, okay? Milligrams versus micrograms. How long must the IV continue for the patient to receive this dose? Okay, second part is, what is 21 milligrams in micrograms? So, earlier in our class, I showed you a conversion rate. Like if you go up the scale, you multiply. If you go down the scale, you divide. Okay, I think that's right. I think, yeah, multiplication and division. So because we're converting to micrograms, right, which is even smaller than milligrams, okay, we multiply to 1,000, by 1,000, in order to get 21 milligrams times 1,000 would give us 21,000 micrograms. So basically, when we're saying 21,000 micrograms, it's the same thing as saying 21 milligrams. It's almost like saying 100 pennies or $1, okay? So this would be your dollar and this would be your 100 pennies. Same, they're both the equal, okay? It's just we're doing it for the sake of the problem, okay? So because we have 700 micrograms per minute, we want to try to make our milligrams into micrograms so it could be easier to work with. So our 21 milligrams equals 21,000 micrograms. Now that we have it converted into micrograms, we divide by 700 micrograms in order to get 30 minutes. So when it asks us how long must the IV continue for the patient to receive the whole entire dose, right? We know that they're going to get 700 micrograms per minute, and we know that they need to take 21,000 micrograms. So if we divide the 700 into 21,000, we know that it's going to take them 30 minutes to receive the 21 milligrams or the 21,000 micrograms. So that's how you do this problem. All right, and now let's do one that takes a few more steps. Number 14. Okay. What is the flow rate in drops per minute for a TPN compounded with 500 ml of dextrose 10 in water and 500 ml 7% Travasol ran in over 24 hours? And the IV administration set is calibrated to deliver 10 drops per ml. So basically the machine is going to drop 10 drops for every ml. Okay? All right, so let's organize ourselves here. What do we need to find out first? First, it's asking, what is the flow rate in drops per minute for a TPN compounded with 500 ml of dextrose, 10 in water, and 500 ml, 7% Travasol, running over 24 hours. Okay? Pretty much it doesn't matter what the drugs are, because 500 ml of dextrose and 500 ml of Travasol equals 1,000 ml in 24 hours. Okay? So this could be anything, and this could be anything, and it would still be 1,000 ml, right? So it's basically saying, what is the flow rate in drops per minute if the compound, or basically if the medicine is 1,000 ml and it's run over 24 hours, in other words. So 1,000 ml over 24 hours equals X over how many hours? Okay? So 1,000 divided by 24 is, you're getting 41.67 ml per 1 hour. Okay, that's for sure. Now, 41.67 ml per hour is what you get if you're being asked ml per hour. But here it says the IV administration set is calibrated to deliver 10 drops per ml. So what do we have to do here? We need to convert give me one second. We need to it's asking for the flow rate in drops per minute for 1,000 ml in 24 hours. So we're still in the first part. So 1,000 ml in 24 hours gives us 41.67 ml per hour. Then we need to figure out drops per minute. Okay? So since our mLs are 41.67 mLs per 1 hour, we convert the 1 hour in order so we can find the minute part now. Okay, drops per minute, mLs per hour. Okay, because our ultimate answer needs to be drops per ml. So right now we have the ml part. Okay, so now we need to know how many mLs is in 1 minute. Okay, in order so we can go down to the third step. So our first step is to figure out how many mLs in an hour. Our second step is to figure out how many mLs are in a minute. And then our third step would be how many drops are in that minute. Okay? So the first step is 41.67 per hour, 41.67 ml per 1 hour. Second, we need to figure out what that means in minutes. So 41.67 divided by 60 is 0.69 ml for 1 minute. Okay? Now we can set up an equation. If we do 10 drops for 1 ml, okay, 10 drops for 1 ml, how many drops will we get per minute if our ml, or how many drops would we get per minute if our ml is 0.69? Okay, let me put ml right there. So 10 drops per 1 ml, and we are now working with 0.69 ml. How many drops do we need? And then you would get the answer 6.9 drops per minute, which would round off to 7 drops per minute in this case. You might need to listen to that again or take a look at it or reread the question in order to understand the 3 steps that you needed to take in this. But ultimately, it's asking you for drops per minute. You have 1,000 ml in 24 hours, but your machine is dropping 10 drops per 1 ml. So in order to find your drops per minute, you need to find your drops per ml. In order to find your drops per ml, you need to find your drops per minute. I believe. Did I say that right? I would reread the question, understand what is being asked, and take a look at what I did here. But pretty much what you need to do is break it down so you can figure out each element of what is being asked. Okay, because the ultimate question is how many drops per minute. Okay, and you're being given different numbers. So 500 mLs in 24 hours, which is 1,000. And your calibration is drops per ml. So you know your drops at your ml, you know how many hours you're working with, and you know how many mLs you have. Okay, and then if you convert it to the 10 drops per ml that you have here, that's how you would get your answer. I would definitely replay or reread this question in order to get a better understanding, because you have to focus on the question and exactly what I did here in order to get the answer. So take a moment, read it over, and I'll see you in the next video. If you guys have comments, just let me know. I'll try to work on the next video pretty soon. But I just want to get this one out there. If you have any questions, put it in the comment section so we can answer it just once. Thanks.